Hello guys, thank you so much for being with us so far. This is Nobleman's Tutors Online. We are bringing physics lecture direct to your very home. So you are welcome to our class for today. I remain Notable Michael. Please, if you have not subscribed to this channel, please subscribe to our channel. Click on the notification button so that when we upload a new video, YouTube will notify you. Also, please invite your friends so that they can join you in this wonderful learning experience. Give us a thumbs up, give us a like if you like what we're doing. Put your comment on the comment section below, and then if you have any challenge or any problem in physics, you can talk to us via WhatsApp. Please don't call me, just put any problem you have on WhatsApp, and then I will respond to your WhatsApp chats. Is that okay? If there's any question that you need me to assist you to solve, put it on your WhatsApp. Don't call me, just put it there. I'll look at it, respond, give my response, and then we'll get it from there. So welcome to our class today. For today, we are going to treat causes of motion. Yes, we're talking about motion. So now we're looking at causes of motion. All right. So right away, get your writing materials and get settled so that we'll go straight to our class for today. So you are welcome. Okay. So as I said, we are going to be looking at causes of motion. Causes of motion. Because we've talked about motion. We've talked about types of motion. So today we are looking at causes of motion. So what causes motion? We know that when the body is at rest, something must make it to move from that position of rest. All right. So we are going to be looking at the various factors that will cause a body to move from rest or to remain at rest. And one of them is force. One of them is force. So what is force? What is force? A force is that which changes a body state of rest or its motion in a straight line. So a force can either be a push, okay? So if you have a block of wood on the top of a table and it is at rest, no force has acted on it. So if you push it, the block of wood start to move, or if you pull it, it will also start to move. So a force can either be a push or a pull. It can be a push or a pull. And then a force can normally make a body to move or to bring a body that is already in motion to rest. Alright? So a body that's already in motion can be brought to rest by a force. So a force is one of the factors that causes motion. Force is the factor that causes motion. So just like I said, a force can either be a push or a pull. And that is what is represented by this simple picture or diagram. So because a force can cause a body to move, it will make the body to move in a particular direction. And because a force has magnitude and direction, it is what? A vector quantity. So a force is a vector quantity, and the unit for force is Newton, right? Force is expressed in Newton, and this is the formula for force. Formula for force is the mass of the object times the acceleration attained by the object, and mathematically stated, it is F is equals to ma. Now 1 Newton is also the same thing as 1 kg. You know that mass is kilogram, mass is kg, and the acceleration is meters per second squared. So 1 Newton is same thing as 1 kg meter per second squared. Is that okay? So 1 Newton is the force required to give a 1 kg mass an acceleration of 1 meters per second. And that is what is represented by this simple equation. Is that okay? So a force can actually cause a body to move when it is at rest, or when the body is already moving, a force can make it to come to rest. And force is a vector quantity. I hope that is clear. Right, so we are looking at types of forces. Okay, so what are some of the types of forces? So we have two main types of forces. We have a contact force, and we also have force fields. We have contact force and force fields. So what are contact force? Contact forces are the force that exists between two surfaces that are in contact. So if you have a block of wood on the top of a table, because the block of wood is in contact with the table, the force that exists between the wood or the block of wood and the table is called contact force, because the block of wood is in contact with the table. So example of contact forces, we have frictional force and reactional forces. We have push and pull and then tension. Right? We have push and pull and then tension. Okay. So what is frictional force? Frictional force is the force that acts at the surface of separation between two objects in contact and tends to oppose the motion of one over the other. That is exactly what I've discussed. I just mentioned now that if you have a block of wood on top of a table, the force that exists between the wood and the table is called contact force. Now, if for any reason you want to push or pull the block of wood over the table, the force that tends to oppose that your motion is called frictional force. You know that when you apply your initial pull or push to the block of wood, it will not move, because there is an equal and opposite force that is opposing that your pull or push. Until that force is overcome, the block of wood will not move. Is that okay? So frictional force is that force. Frictional force is that force that tends to oppose the motion of one body over the other. That is frictional force. An example where frictional force applies is when we are walking. It is the frictional force between the soles of our shoes and the ground that keeps us walking straight or smoothly without we slipping or falling. Without frictional force, walking will be difficult. Yes, walking will be difficult. You can just take an example, like if you are walking on a smooth surface and maybe your shoe has a smooth surface and you are walking on a surface that is a little bit oily or soapy, you know that your foot will not have a grip on the floor. Yes, your foot will not have a grip on the floor. Why? The because the soapy surface or the oily surface has reduced the friction between your shoe and the ground. So because of that, you will not be able to walk smoothly. But if there is a frictional force, if there is no reduction of frictional force, then you cannot walk without slipping. So that is one example where friction exists or where friction applies. Then another one is driving nails on a wood. It is the frictional force that holds the wood to the nail. Right? So friction enables nails to hold pieces of wood together. It is friction that enables the piece of wood to be held together when you drive nail to them. So friction can exist in solid or in liquid. So frictional force between two solid surfaces is known as solid friction. So the frictional force between the block of wood and the table is called solid friction, while friction in liquid is called either liquid friction or viscosity. Liquid friction or viscosity. And viscosity is friction in fluid. So if you look at some fluid, you find out that you can say some fluid are more viscous than other. Like water is less viscous than oil, right? Water is less viscous than oil. So the frictional force that exists in fluid is called viscosity. That the one that is between two solid surfaces is called solid friction. So I hope this is clear. You understand friction, right? Okay. So we've talked about contact forces. Now we have non-contact forces. Non-contact forces are also known as force fields. Right? We said that contact forces, there are forces between two surfaces that are in contact. But for non-contact forces, there are forces that exist between two bodies that are not in contact. So this force does not require the two bodies to It does not require the two bodies to be in contact, but they can be felt. They can be felt, but the two bodies they are not required to be in contact. Example is one, gravitational force. We know that gravitational force is a force that pulls a body to the center of the earth, right? This is the force with which the earth attracts objects to its center. This force is only felt, but it does not require the two bodies must be in contact, right? So when you throw an object up, the gravitational force will pull the object down, but it does not require that the object must be in contact before it will come down. We also have electrostatic force. These are forces that exist around a charged body. We are going to discuss this later in another class. So electrostatic force is also a non-contact force. Then you also have magnetic force. These are forces that exist around a bar magnet. So you know that for a bar magnet to attract a piece of iron, it does not need to actually be in contact with that piece of iron. Mere bringing the bar magnet close to the iron, it will attract the iron to itself. So this is an example of a non-contact force that you see every day around you. So the effect of these forces are felt by bodies not in contact with them. Their actions are felt at a distance. Just like I've said, the effect of a bar magnet is felt without being in contact with a piece of iron. So these are examples of forces. We talk about contact forces and non-contact forces. Then under non-contact forces, we talk about force fields. Is that okay? So these are causes of motion. These forces are what causes motion to bodies. Thanks so much. We appreciate your staying with us so far. Please, if you have not subscribed to this channel, please, what are you waiting for? Subscribe. Click on the notification button so that whenever we upload a new video, YouTube will notify you. Please give us a thumbs up if you like what we are doing. Give us your comment. You can also reach us via our WhatsApp number that is showing on the screen. Tell us any problem you have in physics. We are ever ready to assist you. This is physics class from your normal classroom. Is that okay? So we are bringing physics direct to your home. Invite your friends. Let them come and join this wonderful learning and enjoy this wonderful learning experience. So thanks a lot. And then we are moving to our next class. And we hope that you will continue to visit our channels. And then please get your writing materials always. Just be prepared for the class. Is that okay? Try as much as possible to avoid any distraction, right? So thanks a lot, and you are welcome to our YouTube channel and welcome to our next class. Thanks.